Professor Dr. Metin Tolan is an experimental physicist. He has worked at the Technical University Dortmund, and he just started his new job as the president of the University of Göttingen, an institution which produced 44 Nobel Prize winners. Metin Tolan likes to talk about physics of football, the physics of James Bond or Star Trek movies. He doesn't believe humankind will walk on the planet Mars by 2032, but would be really happy if he were proved wrong.
This Jesus Christ lizard, as the name is saying, is able to run over the water. It looks very funny.
I must check it out. I think I saw it. Yeah. Basically, it does it very, very fast and it splashes all over the place,
exactly. Right? And of course, it depends on the mass. The gravitation depends on the mass. And this is the Jesus Christ lizard. It has a very small mass, and so the speed becomes much smaller. This is also
I should check it out. I should maybe even show this stuff in school, because in school people call me Jesus. I go down go down the hall and people hey Jesus. It's nice to be called Jesus. It's nice character, right?
I can understand this. Yes.
Okay, what about swearing? Are you comfortable with using the words fuck, shit, and goddamn? And the German equivalents? Or should we leave it out?
Well, you can use it. I hope that I will not use it.
Okay. Hello, Mr. Tolan. Thanks for joining, and thanks for being ready to answer my questions and maybe have a small talk about science and related stuff. I'd like to ask you first what your day-to-day job is and what the research you're doing is about.
Yeah, the daily job is that my group and also myself, we are doing research with synchrotron radiation. This is very intense X-rays. These are very intense X-rays and X-ray radiation in order to check or to analyze the structures of mainly biological materials. We are in particular investigating how proteins, these are the structures, the building blocks of life, one could say, how proteins are going to change their structure under pressure, for instance, under pressure conditions, under high pressure conditions. And the reason why we are doing it, because, for instance, in the deep sea, we have very big or very large pressure, but we also have life in the deep sea. Even in 10,000 meter depth, where we have a very large pressure, we still find life. And the question is, how is life doing this? How can life withstand such enormous pressures? And also, when you look, for instance, in an astrophysical context,
could there be life on Europa?
On Europa, on Enceladus, on all these objects where we now seem to know that there is an ocean of liquid water underneath the surface. And if this is true, you must also know how stable life is in connection with pressure, with temperature. And this is the reason why we do research in this circumstance, or why we are interested in the investigation of proteins under high hydrostatic pressure. This is the HHP. This is the correct terminus. And why we are also interested in the fact how these proteins then behave, how they fold or unfold, and what the stability, to learn everything about the stability of these molecules.
Okay, so but how do you create pressure with X-rays?
No, we are not creating pressure with X-rays. With X-rays, we are looking at the structure. We are creating pressure just as you know it by with a special pressure cell. We put water. We are looking at the proteins in solution. And then we can just apply pressure by applying forces to the sample cell.
But the sample cell has to be...
There has to be a sample cell with the protein solution, and then we have mechanical pressure, which we
exactly. But you have to have the middle of the sample transparent to X-rays, right? Like,
yes.
like what kind of material would help?
Well, yes. On one hand, yes, it must be transparent to X-rays. On the other hand, X-rays are able to penetrate even thicker aluminum containers. We are using X-rays with a very high photon energy, up to 20, 30 keV. This means we can penetrate easily centimeters of aluminum.
Okay, so you have an aluminum canister and you analyze there.
But
So,
we also use, when we are really going to even higher pressures, we are using the diamond cells with diamond windows. And diamond is carbon with very low Z materials, and then the absorption of X-rays is even lower.
okay, so have you found something concretely about life that makes it so much different at high pressures that even if there was life under the ice of Europe or Enceladus, it would be like so different because of the pressure?
Well, first of all, it is very likely that life in any circumstance, it depends on carbon, as we are also, as our building blocks are made out of carbon. This is a general feature of carbon and has to do with quantum mechanics, because the chemical variety with carbon as a building block is much larger than the chemical variety with any other element.
Except for silicon maybe, but yeah.
Well, silicon. There is a rich silicon chemistry, but compared with carbon, it's really not considered to be rich. So if life means that you have very complex chemical compounds, then it must be clear that carbon is a basic element. So it's a very good hypothesis that life also on other planets is based on carbon. And this means that what we have here on Earth, proteins or large molecules made out of carbon, that is very likely to have this also in alien life forms, whatever alien life forms are.
So you think, like, it's probably just hypothetical, but do you think that life, if there is life outside of Earth, is kind of like Earth life? Like, would we recognize it as life?
Well, if it is not Earth life, or it is not at least similar to the life on Earth, we cannot even recognize it, because we would not know what are the products of this life.
What do you think about something invisible, because it's kind of like magic to us, because it's so much more advanced technologically?
Well, it can all happen. I mean, our fantasy has no limits, I would say. But as a physicist, I would say the most realistic scenario is that it is carbon-based life, maybe other chemical elements involved, but carbon is the basic building block. And what we also know from our own measurements is that life under pressure, when we are talking about life at Europa, at Enceladus, then nature is able to create small molecules which are able to release the pressure.
How do you mean? Like little packets of like?
Yes, molecules which are connected to the proteins, and then the pressure is distributed over the molecule in a special way. So they are. It is difficult to explain, but they are somehow able to release the pressure. And these molecules, which you do not find in your body, for instance, but you can find these molecules in the body of fish, which is living in the deep sea. These molecules were obviously created by nature in order to protect the proteins. And this is very clever. And evolution is obviously able to adapt an animal or a life form to its surrounding in a perfect way. And if this is true, then of course evolution, and if evolution is what is intrinsic in life, then of course the same evolution would adapt a life form on Europa or on Enceladus on this very large pressure conditions which you have on the outside.
If life started at all, right? Because maybe it's hard to start life at such great pressures, although even on Earth probably did start deep down, right?
Well,
Black
no,
smokers
starting life on Earth was not that difficult because scientists have shown that just a couple of 100 millions of years after the creation of Earth, there were indications that then life was already there on the planet, but very primitive forms of life, just single cells. Then the jump from single cells to life forms made out of many cells, this took billions of years. This is obviously the difficult jump. The difficult thing is not that life itself is being created. At least this is what is the hypothesis at the moment. So when we are talking about life, we have to talk about life composed of single cells or life composed of many cells as we are. So the single cell life form seems to be much simpler than the many cell life forms. But as I said, it's of course all of this is speculation.
Yeah, we cannot go back in time, but maybe we can land on a planet like Europa and dig down. Maybe we will see single-celled life. Maybe they just got stuck or there.
Or Mars.
Exactly, yeah.
Or Mars. This makes it very fascinating for me to look at planets and to look for life, such as the rover Perseverance is doing it at the moment, just right now, on Mars. This makes it very fascinating for me.
Yeah, it was pretty amazing what they did there. They should definitely send way more. Are you interested, or do you think it's a good idea to send the probes to Enceladus and Europa? Because those are my two top targets. Have you read about maybe the possibility of digging down their icy surface?
I must say, I hope that I will be able to witness such a mission during my lifetime, because these missions seem to be very complicated and very expensive. But if I would have, if you give me an infinite amount of money.
Do you need infinite amount, or do you just need $1 trillion?
Amount of money, but the amount of money is.
Yeah, but how much do you think you would need? Like,
the Mars mission Perseverance was 2 billion. And I think the complexity of going to Europa and then having a small robot then melting through the ice shield and having an even smaller robot to take a probe, this is, I think, in terms of complexity, probably a factor of 10 more complex. This could mean that
in price as well,
we are talking a factor of 10 in price. So this is a very heavy mission.
Which is still kind of cheap if you consider how much money is being thrown around because of Corona, right?
Well, not because of Corona, but when I would say my example would be how much money is sitting and is bound by weapons, by completely useless weapons. Then of course we are talking about a cheap mission. But of course other people would consider it in another way. But such a mission with 10 to 20 billion is still, of course, very, very, very expensive. If you ask me what would I like to witness more, a man on Mars or a probe from the ocean of Europa or Enceladus? I would say the second.
Which is your favorite, by the way, Enceladus or Europa? If you could do one of them.
If I could do one of them, or Europa, of course, because it is larger than the ocean seems to be larger, and then the probability that something was going on there is higher than in.
But it's harder to fail. It's harder to get through that thick ice. On Enceladus, at least, you have kind of like a relatively thin ice.
If this is true, Yes, if the ice is thinner in Enceladus, then of course the probability to go through the ice shield is higher, but finding life is not, the probability is not higher, because you need energy. The energy is coming from the gravitational forces and from what is called
the tidal effect. Right?
Tidal effect. Yes, I was just looking for the English word from the tidal friction. This is what it is called. This is higher at Europa than in Enceladus, and of course from the amount of material of carbon which you have, and the probability that there is a carbon core or a carbon-rich core for Europa is higher than for Enceladus, which is a very small object. And then I think it is much more likely to find life in the ocean of Europa. And I think this is a much more exciting mission if you compare it with the mission bringing a man to Mars, which is also interesting, of course.
It's interesting, but it's more of a propaganda thing. I mean, unless you're bringing like a lot of stuff to actually make that settlement sustainable, I think it's all just show, right? And it's all basically showing off.
Well, of course, an astronaut on Mars could make much more sophisticated investigations on the Mars surface. I think so. I think this, but you are right. I think there is a lot of propaganda in this, and having a pure scientific mission to Europa is much more interesting for scientists, maybe not for the general public, but for scientists. And finding something in this ocean of Europa would change our complete picture from the universe.
Totally. That would rewrite who we are, basically. And that would actually confirm or disconfirm how easy it is to have that first step, right, in the Drake equation. Like, how is it easy? Is it to get from mud to something like
exactly. But and this is for me, just to say that this is really for me. I'm doing solid state physics. Well, soft matter, proteins, and so on, but solid state physics. I'm a physicist, but nevertheless, I'm not working in astrophysics. But for me, this is nevertheless the question number one in science. Is life a single event on Earth? Or when you have the conditions for life, will it then grow everywhere in the universe?
Well, it's a question that's impossible to answer. Unless you have gone to all the planets of all the stars to check under every rock, you cannot say for sure, right?
Well, but you can just, when you find life in the very different surrounding of Europa, when you compare it with the surrounding on Earth, this would at least mean, and if it is carbon-based life form with the building blocks of life, at least similar to the building blocks we know, this would give a very strong hint that life, the formation of life, is some, I would say, general development in at least our solar system. But when this is really happening in our solar system, then there is, in terms of physics, since we are thinking that the same laws of physics, that they will also be the laws of physics in another solar system, then it is very likely that life is not an exception.
Although there is like a lot of serious people who credit panspermia as something that could be underlying why even we are here. Like, it's not all clear that Earth just has arisen on Earth. It could be coming from Mars or from anywhere, right?
Yeah, but if we are talking about panspermia, it is just the transformation of the starting of life to some other unknown place.
Exactly, but that might be the reason why there's life in the entire solar system, because maybe there was like one big, asteroid hit that just spread life all over the solar system.
Could be. Could be.
If you had to bet, right? If you had to bet today, let's assume we find life. Europa, Mars, doesn't matter. What would you bet? Does it have the same genetic code as we have, or is it going to be a different genetic code?
My bet is it has a similar genetic code, because the building blocks will be the same.
So you think it's going to be DNA and RNA and proteins?
Exactly, and made out of nucleotides. This is my bet, because these are stable chemical compounds.
Yeah, they're good candidates for life. But do you think that it's also leading to a same codon dictionary, the way you translate, nucleic acids to proteins?
Well, of course, this is a speculation, but I think since life, and we also with our own research, we figure out that the life which we know it is very robust, much more robust than people have thought in the last 30, 40 years. This is a good reason to believe that this robust form of life would also be a good candidate for exist on other planets. Of course, we have no idea if other life forms could be also so robust. But I do not think that all this, what we're experiencing here in terms of life, was just created by chance. Because as a physicist, I believe in some fundamental laws, and the result of all we see in our surrounding is a result of these fundamental laws. And so it's good reason to conclude that probably life is also some of the results of these fundamental laws.
Like there are mountains on every planet in the solar system.
For instance,
maybe by the same token, there's like life on every planet.
And so it's very likely to assume that what we have here on Earth, at least when we have the same building blocks, energy, carbon and water, then also the same result will be created at the end.
So I wanted to ask, if you think that life is probably going to be obeying the rules of physics, I would add that you also need the building blocks. Like if you have a certain amount of heat and energy flow and atoms, then you can start life. Maybe there was not the same energy flow and the same atoms present on Mars, but put that aside. You think that life would be pretty much the same on all these other planets?
This is exactly what I'm saying, and also I wanted to make a bet. I was learning when I was a student that we will never ever figure something out about life outside of our solar system, because
now we know it's bullshit. We can, right?
Exactly. At that time, even physicists and scientists were thinking that we will never be able to detect planets apart the planets which we have here in our solar system. So planets in other solar systems.
Until you do it, it's impossible.
Now we are doing it as a routine task, and of course, I think when the next satellites are being launched, then these methods will be so sensitive that one can look at the atmospheres of these planets.
Sure.
And then I would make a bet. Then we will hear the message life detected on planet XYZ, orbiting around the star a couple of light years away from here. And I think that this message will come during my lifetime. I'm 55 years old.
I sure hope so.
I hope that
how long do you plan to live?
How long I plan to live? Well, I don't know.
What would be like a good number? Like.
No, I will not speculate about 100. I don't plan to get over 100. I must say, but no, I have to say.
By the way, because as a physicist, you must have heard of the futurists, or the people who are trying to convert us to robots and cyborgs. Do you think it's at all feasible to
Well, if we believe that what is going to happen in our brain could be totally transformed to silicon, to a computer, and if we are then still this means if we are conscious, if we know that we are there, if this is really be transferable to silicon, then of course this can happen.
Okay, well, that's one way.
This could even be the next stage. You have a life form made out of carbon, and then this carbon life form transforms to silicon, transform themselves to silicon, and this could be even the next life form, which is then of course a life form then you can live forever.
So that's probably one way how people think about it. I think it's mostly called mind uploading. I'm a big fan of reading about stuff like this, but some other approach would be to try and maybe prevent death, the biological death, because there are some people who are in the longevity space also believe that it's going to be possible, maybe not in the near future, but at some point, to figure out death, like figure out all the ways why people die. And basically this is medicine, right? Medicine has been pushing out like our lifespan. If you extrapolate, medical progress, don't you think it's going to be possible?
Well, with medical, this is what I was just reading, is that the biggest lifespan which is imaginable for us is something around 150 years to 200, because our cells are dividing just a certain amount of times.
Well, maybe you can figure that out, right? Maybe you can tell the cells to keep dividing.
Okay,
there's genetical engineering today. You can.
Well, probably this is true. Of course, you are right. One can imagine all these things. Well, the medicine is doing tremendous progress over the years, and one can think about this. I would only want this for myself if my physical condition then is also as it is, I would say, at the moment, or even as it was 20 years ago, when I can choose. It is no worth to have a physical condition of somebody who is 90 or 100 with all the pain there. This is not worth doing it. So if this can, of course, be the case, then great. And of course, we also experienced this when my grandfather was 60. With 60, he was an old man, a very old man, a really old man. He had to work hard, and he was old. And you could see that he was old. I'm now 55. Well, you can also see that I'm old, but I would say I'm in a much better physical condition than my grandfather was with 55. Much, much better.
Exactly. So you just got to extrapolate that, right?
If we extrapolate this, of course, the life span, the life expectation will grow, and I think also the expectation of being in good condition will grow. I know people who are 80, you cannot see that they are 80.
Yeah.
They are fresh.
It's all in the head.
They are fresh, and I know more and more people who are 80 and are looking fresh. My grandfather, as I said, with 60, he was a really, really old man.
I like to believe that this question about dying is more of like an engineering problem, and think like maybe there's like a solution to this. Obviously, like my ground zero on this, it's probably not possible, at least not in my lifetime, but everything I can do to get some extra years of this amazing life is, I think, worth pursuing. By the way, I had a talk with the CEO of a company who is running in Europe the freezing. Basically, they do cryopreservation and they freeze people. What do you think about that? Do you think it's worthy pursuit?
Cryo-freezing. I think they have to freeze the people over a very long time, number one. And number two, for instance, if then a life form, or if humans in 2,000 years or so are going to start to revitalize the people, I'm not sure if really then the conservation is as good as it should be. we know that we know that very severe injuries of our brain, when they happen, that then it is well, then you have very big problems. I doubt really that this is a real and clever way to do this.
I'll just say it's probably impossible until somebody solves it. But
Yes,
I also think it's far-fetched, right? I'm not betting it's gonna work, but just for the off chance that it will work, you might as well take that bet.
Well, of course, this would then be a really great time for historians who have then witnesses of that of this time. But
I think more historians should read about it.
Yes, historians they of course are very interested. Think about if you can. Whoever George Washington, if you can really make him alive.
I think it's too late for him, but it should be possible for people who freeze themselves today. But on a different note, we talked about how life could emerge like that. Maybe life is just this obeying the physical laws plus some conditions. Are you a materialist in the sense that you think that there is a material reality out there?
Well, a materialist in that way that I believe in the laws of nature, and I think that everything which is around us has to obey these laws of nature. This means, on the other hand, that I'm not believing on spiritual things and things like this. However, something to explain, like our mind, for instance, and the fact that we can recognize ourselves, and this is of course very difficult, and I'm not pretty sure if this is really all based on the laws of physics. I'm not 100%
consciousness could be a bit like more quantum-y or something.
Probably, but I have no real explanation for these things.
Don't you think that consciousness could just be another emergent thing like life?
I'm even pretty sure that this is the case, because this is also a result of evolution, and being conscious gives you a tremendous advantage over life forms which are not conscious.
Well, does it, right?
It does.
We are conscious, and we seem to have made it to pretty high grades of success in the biological sphere.
Well, consciousness gives you the ability to plan.
Is it consciousness?
It is consciousness, because you know that you are there, and you want to be at a certain time at another place. This makes you. This is a real advantage.
But that's just memory.
No, this is consciousness, because you have your own your own image in your mind, and you are planning things beforehand. You have this also in. You can see this also for animals, but there is mostly an instinct, and it's not a real plan. And with a plan, you are also able to change your plan due to what is going to happen. So I think this is the real advantage, and which makes your consciousness, or which is in the evolution, one of the most important developments, that there are animals and also we who are able to be conscious and to plan things which are in the far future.
So how conscious is a dog?
Well, this is difficult to measure, but one measure of consciousness is, does a dog recognize his mirror image, for instance? This is the most primitive measure of consciousness. And there are animals like birds, for instance, they do recognize, special birds, they do recognize their mirror image. And what was figured out is that these birds are also very intelligent. They are able to create very sophisticated tools.
You talk about corvidae, probably, right?
About what?
About probably crows and stuff like that?
Yes, exactly. Crows, for instance.
So you think the crows are more conscious than dogs?
Definitely.
If you had to put a number on this, we humans are 100% conscious. Maybe there's a difference between you and me or between other people.
Yeah.
But how many percent of that consciousness does a crow have?
Well, what I'm not doing is I'm basically not talking too much about these things, because there are really scientists who investigated this, and the level of consciousness I have never investigated. I have just
which is why it would be just like a random guess, like just to have like a hunch about like how conscious, like they have like a tiny bit, or do they have like a proper amount of that?
Well, when I should make it in, as I said, as a rough guess, I would estimate that, for instance, a crow has a consciousness of approximately less than 10%, and a dog less than 1%.
All right. What about a worm?
Yeah, zero.
Like it's not conscious at all.
Because there is no real brain in the worm.
But there is something, right? Like it does learn stuff. It avoids bad stimuli and goes towards good stimuli.
Okay.
It smells. So it has maybe some version of like a percept or like a qualia where he does smell, you know.
Well, now we are at the definition of life.
No, it's conscious. Like a worm is definitely living, right?
Yes.
But is it conscious at all? Like, does it have like some slimmer of consciousness?
Okay, then it's not zero, but it's epsilon.
Okay. So it's all physics. We are made out of atoms, and even our consciousness is a product of an emergence from we having to survive in the forest. But those laws, where do those laws come from? I think physically, maybe you can tell something about it to our audience, but it's all emergent in a way, because at the Big Bang, some of the constants of our universe were actually just created randomly or not randomly, or how this entire story unfolded at the beginning.
Well, there are, of course, this is a very big question. This is a very big question. So I'm not giving the solution. But what seems to be likely for me is the following. Of course, we have all these constants, like the Planck constant, like the speed of light, and like the gravitational constant, and so on. We have all these constants, and they could have random values. But we know that the constants of nature, that the mixture we have is able to create us. When we have just a slight change in these constants, this would not, then you would not have a universe with stable atoms, with stable matter, and so on. This means it could be possible that, of course, there was not only one Big Bang, but a lot of, with many different random numbers for all these variables. And of course, all the other universes, there is just nothing, because they have not created life. And if there is no life in the universe, there are no people in the universe who can think about the universe and can think about life. So
we are here because we can only be in a universe where life was created.
Exactly.
But for that theory, you need to assume a lot of universes, a lot of experimental universes, most of which do not harbor intelligent life.
Exactly, and this is what we cannot detect. So this is, of course, just speculation.
Well, not yet, right?
Well, probably not yet, but I think many of these questions are, of course, just speculation, but as a scientist, I would say if I do not have facts, if I only have a speculation, I can just try to figure out the most likely speculation. And a most likely speculation for which I do not need a god or something, somebody who creates things, and I do not think that there is a creator who has all this created, then it's a very likely assumption that you say, well, there are a lot of universes, and they have experienced some constants of nature, and the single one where the constants of nature have been chosen in our way so that atoms and molecules and very complex molecules can be formed, that this universe, as the universe, we can recognize, where we can do experiments, which we can detect, because this is the logical explanation why our universe is how we experience it, because otherwise you would say, well, this was all by chance. This happened by chance. That Planck's constant is 6.6234 and so on times 10 to the minus 34. This was just an accident by chance. That the speed of light is approximately 300,000 kilometers per second. It was just by accident. This is what I also do not believe.
Okay, so you would lean to credit the most likely explanation to why this is, namely that there are probably a bunch of universes, maybe
a bunch of universes, and we are sitting in one of the universes, and we can detect the universe and figure out that there are special constants of nature because they have created us.
Okay. We have no idea what dark matter and dark energy is. Do you think that revealing that could basically give us some understanding to
Yes.
more? I think maybe to even that, like, if
Yes.
Are there other universes?
Yes, because what we know from dark matter and dark energy is that most of the universe is filled by what is called dark energy. Their name is, of course, mysterious because there is no idea what this could be. And dark matter, we know that what dark matter could be because at least there is a gravitational force, which obviously is needed to explain some large structure in the universe. But we still do not know what this could be. So if we take the dark energy and the dark matter, then we have 95% of the content of the universe. This means, in other words, we are 5%. Matter is just 5%. This means also we have our understanding of the universe consists of 5%. There is a lot of room for future generations of scientists and for future explanations and for future people who will make a lot of discoveries. And there is also a lot of room for speculation, of course.
So let's speculate some more, if you don't mind, because I'd like to know what your idea is about quantum gravity. A lot of people call it different names. You can call it quantum gravity, the theory of everything, or the great unified theory. Let's call it the ultimate theory that will describe everything, out of which equation every other equations are just derivatives. Do you think, first of all, that such an equation exists and we can find it?
Well, I think that such an equation exists, and I also think that we can find it for the following reason. We know from quantum theory that this is a very accurate theory in terms of explanation of experiments. We can do experiments where we can measure certain atomic factors with 13 or 14 digits behind the comma. We can calculate then with quantum theory these 13 digits, exactly the value of these 13 digits. This means quantum theory on the atomic level seems to be very accurate, seems to be a very accurate theory. And the more we look into some pieces, the more we have to take quantum theory into account. So on large scales, we do not see the quantum theory because of the large scales. But when you combine large scales now with large gravitational fields, then of course quantum theory may be again of importance, and it is highly likely to assume this. But of course, to assume this,
and it is
in science you can never know. Science is not wishful thinking. You have to have experiments, and you do not know how to explain them, and then you need a better theory to explain the experiments. At the moment, when we do the experiments at all the large accelerators, for instance, the theory is able to explain all the experiments. We have not seen dark matter, for instance, at the LHC, although people were hoping that one could see it. This is a discrepancy at the moment, that our theories are very successful to explain all the experiments we can do on Earth. On the other hand, the big picture of the universe, we have no idea how to explain this. And this connection of the two, this is really difficult at the moment. But I'm absolutely convinced that there is something like quantum gravity. But it is, of course, tough. We know that it is a highly nonlinear theory, the general theory of relativity, which is by itself extremely complicated. And as we know, a quantum gravitation will be even more complicated. And
well, will it? Right? Like it's not.
Well,
guaranteed.
it will. Well, it will. It will. There is. That there is a very simple theory. I doubt that this is the case.
Because if we assume that quantum gravity will include Einstein's equations, then it must include it, right? Like the quantum gravity must include both quantum mechanics and general relativity.
And general relativity is highly nonlinear. Even the simplest equations are not simple to solve. And so it is highly unlikely to think that there is a very simple equation from which everything follows. This is unlikely. Of course, there could be one simple equation at the end, but when you then look into the equation, then it turns out to be very complicated. For instance, Einstein's general formula for the general relativity. I could write it here on the blackboard. It is just this size.
You mean it's not E equals mc squared? It's
no. It is
the mass with
mass with curvature. The connection of mass and energy on one side, and on the other side is the curvature of the space-time. This equation, when you write it down with a mathematical formalism, it's a very simple equation, but it only looks simple. When you then put numbers in for a special case to calculate something, then all the non-linearities show up. And in fact, you see that this is not only one equation, these are 20 equations, because you have indices. So being simple means not that an equation is always simple. E equals to mc squared. This is a simple equation. Yeah. This is a very simple equation.
Don't you think that this is exactly like a computer program that has an algorithm? If then, like it has the parameters, it has the objects, it has the...
No. This would be true if we were living in a mechanical world. But since the discovery of quantum mechanics... Guess
what? There are quantum computers.
Well, quantum computers, but also with quantum mechanics, we are talking about probabilities, about an outcome which is not certain. And quantum mechanics gives you the possibility that things are not determined from the starting conditions.
Yeah, but so something, if that's the only difference between a mathematical universe and the computer, then maybe, again, like you can just take a quantum computer and you can simulate all the quantum weirdness.
If a quantum computer is possible to build of this size,
people have
probably yes. Probably we are quantum computers.
You mean our universe, or
No, we, our brain.
Could you elaborate on that?
Well, we must explain why I, in this moment, can raise my hand and I can put it down, and this is what I am doing at the moment. This I can definitely not explain when everything is determined by the initial conditions.
Well, the initial conditions are your brain.
Well, yes, of course, one can think about this, but the initial conditions would be determined by my birth, for instance. No?
Then and
my
even
brain
your mother,
is given,
and of course, yeah.
And then, of course, you would say that during my birth, it was already fixed that at that day, today, at 25th of February, in the year 2021, I wanted to raise my hand.
Kinda, yeah.
Could be, very unlikely, I would say.
Okay.
So,
because of quantum weirdness.
If this is quantum, I don't want to say this exactly, because there are a lot of books on the market where I think they are...
The Deepak Chopra kind of bullshit?
Yeah, they are bullshit. I would say bullshit. I'm now taking this word. All what I'm saying is, I have to explain why this is possible, why I can make the decision to do this. This cannot be predetermined. If we would live in a Newtonian world, then this would be predetermined. Then this decision could have been done during my birth, or even by my parents. So there must be something between that I'm able to raise my hand because this is my free will and I can put this hand down.
Well, is it your free will or is it randomness? Because there are those random things that happen at the molecular level because of quantum mechanics.
Could be.
That introduce some randomness, right?
But could be, you're right. It could also be randomness due to many particles which you have. These are the laws of thermodynamics, for instance, which they are telling us that a system is going always to the most probable condition, or most probable. How can I explain this?
The most statistically probable,
scenario or whatever.
It's going to lower entropy, right?
Exactly.
Higher. Sorry.
Entropy is a word, higher entropy, and with energy you can even lower the entropy. This could be an explanation, but could this really be an explanation for such a special movement? Because if a system develops to higher entropy, this means the whole system develops in this direction. This is a really tough question.
Yeah, so, you and me, we are both very low entropy compared to the environment, and I think that's precisely what makes you human and makes you be able to raise your hand or not. I think it's mostly about accepting or not the premise of randomness or free will, because I do believe that you can just explain it away by randomness. I do not think you can explain this by free will, but I do accept that we have this pseudo free will, like the illusion of a free will. I think we are pretty predetermined, even in a quantum world. Let aside a couple of quantum weirdness that could be so random that add up.
Illusion of free will? I don't think that I have an illusion of free will.
You think you have actual free will?
I think I have actual free will. I hope so.
Well, you hope, so. Right? Exactly. You hope.
I hope so. And no, I think that it is really interesting to think about really the origin of free will. This is a really interesting topic. And when you are a physicist and when you believe, I say when you believe on the natures, on the laws of nature, then it is really interesting to incorporate the free will into this. And I have also just given, and I have to say this very clearly, a speculation, because quantum mechanics is the only theory I know where you have uncertainty, where you have just probabilities, where the same experiment can have two different outcomes, This is in no other theory the case, except what you were saying, thermodynamics, where we are talking also about most probable scenarios. This could be a second explanation. If you ask me what I prefer, I would still prefer quantum mechanics, because the entropy explanation is just going in one direction, while quantum mechanics gives me more freedom. However, there is absolutely no proof that quantum mechanics is important in our brain for the at all.
Exactly. And I would argue, if it's relevant, its randomness is very at the molecular level. Like, if it makes any difference,
yes,
if there is a quantum uncertainty or not, it's at the molecular level, and our brain is so big that it just averages out. I think that
but on the molecular level, this means maybe for one or the other chemical reaction, this changes the reaction rate.
Exactly, but it changes the reaction rate, in this way here and the other way there. And
could be.
That's my thinking. I'm a hardcore, die-hard materialist, and I really think that we are just a bunch of atoms, and we just obey the laws of physics. And this conversation was predetermined.
We are not. Well, yes, we are not far away with our opinions. I must say. I'm also. I would say now in percent, I agree to your opinion to 95%.
Okay. But here's the weird part. I'm an agnostic, and I'm also a very grounded agnostic, because I do not know if there is a God, because precisely what I told you about the mathematical nature of the universe, it's just so mathematical that there must be some kind of computer that it's running on. Like, I call it computer because I don't have a better word, but it's very weird for me that our universe is so guided by rules, and again, the same rules that lead to me, saying the words and destroy my free will, are the same rules that make everything in this world. And the other thing that I know that is so linear and so like predictable is a computer. There's no other thing I know. And the next question is, who is sitting behind this computer? We are humans. We like to tell narratives. Maybe there's nobody sitting behind this computer. Maybe that just is. But I think that's an even bigger question. Like, why is there something rather than nothing, right?
Yeah, but I do not think that such a question is really bringing you to a point where you can stop. If you ask if there is somebody sitting behind the computer, then you must immediately ask yourself, who puts this person behind this computer?
Or maybe I can figure out,
Well, and then you have to ask, who is the person who puts who puts you behind the computer?
I think it's a very exciting journey to first find the first dude, and then maybe look for the other one, one level down.
When there is no first, because you can always ask what was before, except one accepts that there is no before.
I think the only way to find out is to look at the stars and study dark matter and all that stuff, because I think that could lead us to some answers. And by the way, do you think that if we have the equation of quantum gravity, do you think that could potentially give us some clues to stuff like that? Like how our universe came to being?
I hope so, because quantum gravity will be valid at the point of the Big Bang, for instance, will be valid at all the points where our normal laws of physics break down, at black holes, for instance. And this is the reason why I hope that quantum gravity gives us, or will give us, answers to many of the very big questions. And I also hope that there will be observations in the universe which gives us a hint towards the right theory, because just making a theory without having then the possibility to do experiments and to explain these experiments, this has no worth. We can
produce predictions.
Well, we can see this in the string theory, for instance, a theory which is around for more than 30 years, and obviously which is not able to make a prediction which you can prove by an experiment or disprove. Such theories are interesting because you can entertain your mind with them, but they're essentially useless, I have to say.
Yeah, I think so too. Speaking about uselessness, do you think that if somebody figures out quantum gravity, that research could give us new technology? The same way as relativity and quantum mechanics give us a lot of new technologies.
Well, first of all, I think that every type of research has given us sooner or later benefit for problems which we have faced sooner or later. So research itself is not driven by the need of the society, but later on gives an add-on to the society. There were many examples, and so I think the same will be with quantum gravity. At the first glance, everybody will say it's completely useless. It's just for our mind, or we have understood our universe a little bit better. This is certainly what will happen, but sooner or later, I think that there might be applications where we have to take these findings into account, otherwise they would not work. I think GPS is one of the most prominent examples, which we all use and where nobody knows that it depends on our understanding on general and special relativity to theories developed from more than 100 years ago, where people were thinking, well, nice. Just nice. So
just on my phone, it works, right? Of course.
Exactly. You can never
quantum
know.
mechanics, like it needs quantum mechanics understanding to fabricate those chips that are in the GPS device.
Exactly. And it needs not only quantum mechanics, general theory of relativity. There is a correction in the time signal. Special theory of relativity. There is a very big. Very big correction of the time signal. So all kinds of thermodynamics, because your cell phone heats up. Of course, electrodynamics. All areas of physics are covered by this. So I think that all this will make an impact. You can ask, by the way, the question already for particle physics. We have quarks and the Higgs boson. So what is the use of this? For particle physics, I have to say the use is already very indirect. If particle physicists, they were the first people who created so much data that they were thinking about connecting computers.
They were, at CERN, they were pioneers with the internet.
So they invented even the World Wide Web. And if I really doubt that the World Wide Web would have been invented by engineers, because at that time nobody could even imagine that it makes sense to connect computers. For what reason?
You're mad? What? Like, it costs a lot of money.
And the most difficult questions are the questions of basic science.
Yeah, and the most interesting ones, if you ask me.
We were saying the most interesting ones, but the normal public is certainly not of the opinion. But one can always say these are the most difficult questions. And so we have to develop tools to tackle these most difficult questions with the best developed tools. And this is the reason why we have inventions which are coming from from solving these questions. For instance, these glasses here. I have glasses with a glass where the refraction index is continuously varying from here to here, so that I can look, or that I can recognize things at the door sharply, and also here which are very close to my eyes. And this invention was based on an astrophysical invention where astrophysicists were asking about for glass where the refraction index can be varied continuously in a very definite way in order to make images from stars, very sharp images from stars, and to correct things which coming from the atmosphere. And without this question, nobody would ever have thought about manufacturing glass with a continuing varying refraction index. And it was certainly triggered by this very important scientific question to look sharply into the universe and to make images from stars. And I think before this, nobody was even thinking about creating a glass with a refraction index which is continuously varying.
Yeah, same thing with space exploration. So many technologies that we take for granted today come from space science just advancing and inventing new materials and better rockets.
So these are the side effects. We will certainly have side effects when quantum gravitation will be developed. We will have side effects definitely. The discovery itself, we will see. Who knows if in some far future we need even more precise clocks or watches to measure even more precisely distances.
And somebody will invent that, and that will trickle down to the general public, and 10 years later everybody's going to have like a super precise clock in their phone.
Yes.
But is physical research, fundamental research, getting enough money these days? Is this a problem of money, or is it a problem of brains?
It is very easy nowadays to complain that there is not enough money allocated for fundamental research. I am not one of these people who are saying this. I think there is a lot of money in the system for doing fundamental research. And I'm also saying that, at least I can say this for our university here, I do not know about a single good idea which has not been realized due to the lack of money.
Okay.
Probably I do not know all the good ideas of the university. Yes. But I can say this for my group, that when we had a good idea, we wrote a good proposal, the proposal was granted, and we got the money.
Good. That's really good. That's good news. It's a rarity these days.
Having a mission, I would start a mission to Europa, where we were to Europa, and really to look if there is life or not. Of course, for such missions, obviously there is not enough money, because I would like to start this mission now.
Okay, well, hold on, because there's weirder and more expensive stuff yet. What about colonizing Mars?
Colonizing Mars?
Like not just flying there and putting down a dude.
Yeah, colonizing Mars is for me more or less science fiction. I mean, I'm not...
If you have a minute, I think I could share my numbers with you, because it's kind of interesting that I thought about how much money it would take for how long to get 1 million people to Mars. 1 million people is, for a lot of people who have thought seriously about this, is the kind of population that you need for a sustainable, self-sustaining colony. Anyways, how do you get 1 million people plus equipment plus a lot of material to Mars? Well, the best bet that we have currently to get to Mars is maybe the Starship out of Texas, Boca Chica. Maybe there's going to be something better. I hope that it's going to get better, and there's going to be like different companies. But let's just assume it's about the Starship. Okay. How much would it cost? And if you're on the numbers, like how many people you can fit in there, how many stuff you have to bring. $100 billion per year is my pessimist figure about this. And $100 billion, that's something like 5 or 6% of the U.S. Federal budget. It's 1% of the U.S. GDP. No, wait, 0.5%. 0.5% of U.S. GDP.
It's even less. The GDP of the U.S., isn't it?
Like 20-something trillion, 23 trillion.
Trillion. Oh, you were saying of how much trillion? 100 billion?
25 trillion is what they got as GDP, right?
Yeah.
And 100 billion was like, less than a percent.
Less than a percent.
Half a percent. Let's run it for Germany. So Germany is, I think it's something about $4 billion.
Yes.
It would be 100 billion. How much is that? I think 2.5%.
4 trillion means 100%. This means 400 billion is 10%. 40 billion is 1%.
It's 2.5%.
2.5%, yes.
I'm not sure how much Germany is spending on the military or on some bullshit,
Well,
Germany could run this.
We are spending approximately 40 billion on military.
Only 40, okay. I know in the US it's something like 600 billion.
In the US. In the US, you have the military budget in the US is almost double the complete budget of Germany, of the federal budget of Germany.
That's not. I don't think it's true.
We have 400 in dollars. We have 400 billion of federal budget in Germany, and you have I think 700 billion of military budget. Not quite 2 times, but almost 2 times.
It goes to show how.
Which is interesting. Which is very interesting.
Interesting. I would say fucked up, but okay. Let's stay with numbers. So 100 billion. What will it get you, right? So NASA has a budget of 20-something billion per year, and they spend the money on a lot of different things. And I think they allocate maybe 2 billion per year to something like getting rockets to Mars. So currently, to launch a Falcon 9 or any other rocket, actually, even the European rocket, the Ariane, it's about $100 million, right? Yeah. So for a big rocket, you pay $100 million. A rocket that's not reusable, a rocket that's whatever. But if you assume that that's how much it's going to cost to launch a Starship, that's going to be reusable and cheaper and whatever. Well, then it gets you 1,000 launches for that 100 billion budget. And 1,000 launches gets you a pretty long way to start to colonize Mars.
Well, this seems to be, this underestimates the real costs, I would say, tremendously.
How tremendous? Like 1 or 2 orders of magnitude? Because
yes, I would say 1 to 2 orders of magnitude is pretty sure, because number one, the Starship has to be big, very big.
It is big.
Very big. I mean, we all know the rocket equation, we call it, and the rocket equation is very frustrating because of the logarithm in the rocket equation.
Yeah, but sorry, but it doesn't. It's not supposed to do one stage to orbit. It has a booster.
Yeah.
That will bring it up to orbit and will refuel it in orbit.
Makes it not cheaper.
Well, it makes the actual Starship, the Starship that's actually going to go to Mars.
Yeah, there is also the idea to put a colony on Moon, and then you can go more easy to Mars.
But that's bullshit. It's actually harder to go to Mars from the Moon.
Yeah, this is all. I have to say, well, first of all, please go back to the Moon.
It would be a good idea, yeah.
This would, I mean, just showing that we can easily now go to Moon and bring an astronaut safely back to Earth. Just show me this. At the moment, I mean, if people are getting excited that SpaceX, together with NASA events, is able to put 2 astronauts to the International Space Station 300 kilometers away from here, and people got crazy about this big success in the last year, I would say, well, if we are excited about this, and then people are speculating about going to Mars, I can tell you, I hope that during my lifetime, I will get the message, life detected on a planet because there is a certain composition of an atmosphere, or even electromagnetic waves from created artificially have been detected from a planet where we have detected an atmosphere. I think I will witness this during my lifespan. What I will not witness during my lifespan will be a single astronaut putting his foot on Mars. This is also my speculation.
Interesting, because I know for a fact that NASA has planned to land a person on the moon by 2024. They kind of extended that to 2026.
Yeah. They have planned on 2024. They have planned to do this on 2020, 10 years ago. They have planned to do this on 2016, 20 years ago. They have planned to put a person on Mars on 2030, 30 years ago. All this is bullshit. I mean, if I see really the progress in terms of really putting people in the orbit or to any other place, the progress is marginal. It goes even back.
Well, if you ask me, I'm a part of this young community of space enthusiasts who is seeing and watching very, very carefully what's going on in Boca Chica, Texas. And have you been following that stuff?
No.
Like what SpaceX is doing? Basically,
yes, I know all the nice computer animations which are going to be produced.
Have you seen the actual rocket? Have you seen the actual rocket fall and blow up?
I have seen this of course, I watched the launch of the SpaceX orbiter. This is what I launched, but it is not convincing. It is really not convincing.
It's not supposed to go to Mars. You mean the Dragon spacecraft,
yeah.
Right? It's a little stuff, for International Space Station to play nice, but it's not about that. If you have seen the big, stainless steel rocket, pointy shape, like a pointy.
A Saturn V rocket was 100 meter in size, and it must be that big.
It's going to be bigger.
Well, yes, but
so the Starship is going to come on top, and the booster, the BFR, the big fucking rocket, is going to come underneath, and that's what's supposed to accelerate the Starship out of orbit, out of the atmosphere, and after 100 kilometers, the Starship's going to take over. It's kind of figured out, and it's made to.
I am believing in the laws of physics, and also Elon Musk is not able to beat the laws of physics.
No, but I think he has a good understanding of the laws of physics too. So.
Well, yes, I think his understanding in creating computer animations is much better.
He has no idea how to create computer animations.
Well, but
maybe
the laws
fans.
of physics teaching us that you cannot beat the rocket equation. This means for each kilogram which you want to take to Mars, you have to have hundreds of kilograms of fuel. So this is what you cannot beat.
The good thing is we got a bunch of fuel, so.
Yes, of course, but then you have to put a new price tag on your rocket.
You know well that the price of a launch has nothing to do with the price of fuel. It's something like $100,000 for fueling the biggest spacecraft, something like that.
Well, yes, but the only thing I know is that the ratio of rocket with fuel to rocket without fuel, this is the ratio which is of importance for the speed of the rocket. You cannot beat, or you cannot really become better than, I would say, 7-1 or 10-1.
Oh, which is why you have to build big rockets, because the bigger the rockets, the less material you need to confine it. Which is why Starship and the BFR is bigger than ever. It's got like 9 meters.
I will watch this very closely.
Please. But you're saying today you would bet against humanity getting to Mars by 2030.
Yes.
Make a bet?
I would definitely bet 2030. You are saying this means in 9 years.
Yeah.
I would definitely bet. I would even bet my house. I would tell my wife.
Don't bet your house. Your house is worth a lot.
My house is worth a lot, and I would
Okay,
tell
let's make it 2032.
No, 2032. 2032 is the year of my pension.
So what about that?
I think it is absolutely impossible. That
I think it's
happen.
absolutely possible, and I'm willing to take that bet. You wanna bet? I don't know,
Okay.
maybe an ounce of
bet?
gold.
Well, not my house. My house is a little bit.
Yeah, let's bet an ounce of gold. That's pretty much, I think, the only thing that has value in 12 years.
What do you mean?
An ounce of gold.
An ounce of gold.
You know, I'm like a big fan of gold.
Okay.
It's worth 1,600 euros today.
Yeah,
So.
an ounce of gold. We'll make the following. Please send me an email with our bet. So then we have the bet fixed.
2032, the 31st of December.
Okay. You got.
If there's no motherfucker on Mars, I lost my bet, and you get an ounce of gold.
Great.
But if there is somebody, then I get my gold.
Ounce of gold.
Cool. You're still gonna lose. Is it a good idea, by the way? Let's assume that my numbers are right, and it's gonna be actually kind of cheap, and we can send 1 million people to Mars with $100 billion per year. Should we do that?
I don't know. I don't know if one should do this. If you find these people, why not? I must say, why not?
You're gonna find. Here's one.
Well, if it is, I would never go to such a trip, I must say. But this is just me because I have.
But most people would not take the trip, yeah.
Well, yeah, but I have never been very I was always shrinking away for things, for dangerous things. So I would never go into such a rocket, for instance. These are real heroes for me who are doing this. They are really sitting on top of a bomb, of nothing else than a bomb, and I would never do this. And also, if you look at the ratio, how many astronauts died compared to the number of astronauts, then the probability to die is in the per mil range, which is very high. No way with me. So is it worth doing it? Of course it is worth doing it because this would be a technological achievement which is really great, and I think the benefit for the whole world would be great. These people would just be like the first people who went to moon. The fact that they put their foot on the moon is essentially useless. I mean, they put their foot on the moon, great, and they go back. And the fact that for more than 50 years nobody touched the moon again shows us that going to the moon itself is not a very interesting scientific task. But going to the moon has triggered so much technologies. For instance, our computer technology would not have developed in that fast time span without the landing on the moon.
Yeah, I just read today that at that time, half of all the production of computers went into the space program. Half of all computers that were fabricated in the US went straight into NASA.
This was for technology. It was really a jump, and this was definitely for the benefit of the society.
Exactly, and I like to say that all the dollars that were spent on the space program, those dollars actually ended up in the U.S. economy. It was not like sent in a rocket to the moon. It was actually all spent on Earth.
In the U.S. economy, and also due to the technology developments, they were not only spent in the U.S. economy. They paid back 10 or 100 times, certainly. And when you look at the economic numbers of the United States, you can even see this boost. So, but this was one common target because there was a Soviet Union who launched the first satellite, who put the first man into an orbit of space, and it was this race between the two superpowers. Now I do not see a race.
Well, maybe soon there's going to be something with China.
Yeah,
I think something is really shaping up there.
if there is a race, fine. Then this would certainly speed up the program. But without this race, you will not see any big development in this case.
Yeah,
I
I'm
think
afraid
at
to.
least.
Yeah.
I think even Elon Musk or Jeff Bezos, they are not rich enough to afford such a mission.
No, I think they have in the range of 200 billion as stocks, like in their pocket. So it's not definitely not enough. What about if you were the Chancellor of Germany? Would you unilaterally like give some more money to space exploration? Would you undertake something that crazy, or would you just like give a bit more money to maybe go to Europa?
Well, when you are a chancellor of a country, of course, you have very many things you have to care about. And of course, with me as a chancellor, the expenses for the military budget would really go down to the minimum level you need. Of course, this has also then political consequences, but I would really try to put the minimum amount in it. For instance, when a president of the US would ask me, how much money do you spend for the military budget, I would tell him, well, we count all the money we spend for the refugees also to the military budget. Because this is that we have the refugees in Germany is a consequence of a war the United States is initiating or has initiated in Arabia. So these are also military expenses. Yeah. And I would, of course, do a lot of more in science, and of course, I would try to put money in space exploration, not by man, but by robots. Because the questions to solve are, for me as a scientist, much more interesting to look in the ocean of Europa or Enceladus rather than putting just one person on Mars. Although this person on Mars is then, of course, able to do much more exploration than a robot.
And that would mean way more glory for the country who puts that man there.
Glory for the country, yes, but if you are the first country which detects life on any other planet, it's also good for the country.
Yeah, it's a nice PR move. You're gonna be in the history books. Like it's in the history books now that the Americans walked on the moon first. Nobody's gonna rewrite that. They did it, and they are great for that. Are they gonna be great for discovering life on Mars? Maybe, or maybe not. But talking about big mysteries to solve, is there like the one mystery that if you could choose for free, one mystery to solve, what would that be?
One mystery to solve is, of course, the mystery, is it enough to have energy, carbon and water and some other chemical elements to create life? Is life then automatically created or not?
So you want to have a ticket to 4 billion years ago and check out what went on in the ocean?
Yeah.
I think it's a worthy mystery to want to burn that opportunity on.
This is for me still the biggest mystery. Is this all? Is evolution a process which is happening automatically when you have the right mixture plus energy? Or are there other things you need for bringing this to happen? And I think this is really the biggest question you can solve.
As a human, I think that's an extremely interesting question, but maybe what about the other parameter in the Drake equation where we become humans out of monkeys? How likely you think, compared to just like life appearing, like how likely is that we get to be the humans that we are?
Well, all these are questions which are coming after this first question. After the first question, because if the answer to the first question is no, that there are other things which are needed, then creating life becomes more and more complex. makes it more and more unlikely to find it on other places.
But what do you mean? What could be that thing that's needed for life?
Yeah, probably certain compositions, a certain amount of carbon and a certain amount of nitrogen and a certain amount that only when you have these certain amounts that then life is going to form.
Well, you have a big enough planet.
Of energy, a certain amount of, I mean, all these things can be, can also be prerequisites for developing of life. If this is true, then of course it's highly unlikely to find life everywhere else in the universe. If just you have carbon, water, energy, no matter what energy, then of course we know already that there are a lot of places where life is able to be developed. And so I think this is really a very tough and a very interesting question, and it really is a question where I was really, where I'm thinking about, I would say, well, since I am at the university, I must say. Of course, there are also other big questions about the Big Bang, about dark energy, and all these are also interesting questions. But for myself, the question of how develops life, what is really needed, is still the most important question. It's just my perspective.
I myself feel like I'm a part of the entire ecosystem, the entire biosphere, and as part of the biosphere, I must concede that this is a exceedingly interesting question. What do you think about, just as an opinion, about the question, why is there something rather than nothing? Do you think it's a crucial mystery to solve?
You mean why is there something rather than nothing?
Yeah. Well, why does the universe exist?
Well, this question is a little bit too big for me, I must say.
Well, isn't it the same kind of question as like how can life arise?
In a certain sense, it's the same question, because the origin of life is also the origin of us, the origin of the people who are now thinking about the origin of life. Yes, it's true. I think the question of the origin of life is more simple to answer sooner or later than the question of the origin of everything.
Yeah, I think so too.
So what I have learned in my life as a scientist, well, try to find problems which are, number one, interesting. All the problems we discussed are interesting, but number two, where you at least have a small chance to come to a solution.
Yeah, great
and
thing.
I think that the origin of life, we have a small chance to come to a solution. The origin of everything, well, probably sometimes.
Well, maybe it just takes one bright mind to figure out quantum gravity, and maybe quantum gravity is going to give us the key.
Maybe.
So, what about intelligence? Is intelligence possibly a next step in our evolutionary ladder? Is something like super intelligent artificial intelligence gonna be the next level of our civilization?
Well, intelligence is also a word which has to be in a scientist, of course, must define the word intelligence. There are certain different definitions of intelligence.
And I'm going to talk about all the different intelligences, in fact, but let's first talk about the intelligence that supposedly could arise from a computer that's taught to reason, that's taught to recognize pictures, that's taught to recognize voice.
Yeah.
Do you think that there's something like that could happen, and also which recursively could improve itself, thereby making itself smarter?
Well, intelligence, of course, is also a product of the evolution, and our intelligence made us also superior over our surrounding, of course, over animals. Clearly, this is the case. We can just look on Earth. The humans have shaped the planet, and this is, of course, clearly proof that our intelligence has made us superior, and so it was an evolutionary advantage to have it. It would also be an evolutionary advantage if it is possible to transfer my brain and my intelligence to silicon. Then this will happen, and then everybody will do it, and the result will be a society made out of silicon, definitely.
Yeah, but what about doing this without the people?
What do you mean without the people?
Like a computer just starts to find its own consciousness. A computer would just wake up figuring out everything because he will just grow in intelligence exponentially.
Would be very interesting. It would also be very interesting then to decide to switch this computer off.
Well, I think it's arguable that you cannot switch off something that's more intelligent than you, can you?
Exactly. Probably this computer will then prevent you from switching him off. I would do this if I were, if I would be such a computer. The first thing I would think about is how can I prevent somebody to switch me off. So, if evolution is then still the driving force, of course, I think artificial intelligence is nowadays a very interesting field, and I also think that the developments there are tremendous, really tremendous. I could see it because I wrote a book about the physics of James Bond, and I wanted to make an English translation. And I asked the publisher, well, I have really no time to do this. Can you do this? And they were telling me, well, it's enough to have a DeepL translation. This is a translation program, DeepL. And then we can work with this. And I was just looking at it, and then I made a DeepL translation, a Word document of 300 pages. I put it in, and it took the program 2 minutes to make a translation, and it was completely formatted in Word format. I just then had to put in 1 day of work to tell the program or to correct things like 007, for instance. The program was not able to recognize that this is a person. Of course. But probably the next time it is able to recognize that this is a person, but just a single day for 300 pages. Wow. And when I did this, I was thinking, oh, wow, this is artificial intelligence, and the job as translator will not be very safe in the future.
Probably not, yeah.
And it was obviously good enough for the publisher then to show this translation to a native speaker, which they wanted to do in any case, to brush it a little bit up and to put some sloppy wordings in it so that it sounds like James Bond, for instance. This is, of course, a development which I was not aware of. That translations are obviously so perfect already that you can see that here a sort of intelligence is developing in such a rapid way, which we have never seen this in nature, of course. Evolution is a very slow process. And so you can never know what will happen in, say, 20, 30, 40 years.
Yeah, but I think that one thing we can be certain of is that they're going to get better and they're going to get smarter. And maybe there is not going to be a so-called intelligence explosion, because these AIs are very specific, very narrow.
At the moment, I must say, to solve a special problem, intelligence in nature, in the evolution, was also very narrow, because an animal had to solve a special problem in a special surrounding to get, for instance, food or whatever. But it became then also wider and wider when the animals were able to move to different surroundings and to adapt to different surroundings. What I am impressed by is the speed with which artificial intelligence is developing right now. It's an exponential speed. And what
processing power is exponentially growing.
Exactly.
So
well, processing power, it's not always processing power, it's also algorithms. Algorithms help a lot.
And they are getting smarter, and a lot of a lot of bright minds now are sucked into this field because it gives so much money so fast.
In 1996, or was it 1997, the world champion in chess, Garry Kasparov, was beaten by an IBM computer which had the size of this room here. 10 years later, the champion in chess was beaten by a program which you just could put on a CD. 10 years.
Running on a laptop, probably.
On a laptop or on a PC. 10 years. And this is really fast.
And the game that a lot of people think was the crucial one is Go. And now have you heard of AlphaZero?
Yes.
AlphaZero, guess what? It beat the best Go player.
Yes.
And the weird thing about it is AlphaZero learned to play Go in like 1 hour from itself, from nothing. Like it didn't get the rules. It just started playing with itself.
Yes.
Defeating the world champion like it's nothing.
Yes. So it is not just the artificial intelligence. For me, it is the speed of the development of artificial intelligence what makes it really interesting. And I think nobody can really see what this means for the next 5, 10, 20 years, because it's an exponential speed. And what exponential mean, we all know now in the corona crisis what exponential development means.
Well, most of us have learned it, yeah. I think there's still a lot of people out there who are not really up to date with it, but exponential. So talking about intelligence, let's talk about the other synonym or the other meaning of it, which is IQ. Do you know your IQ?
IQ, well, the IQ. I must say, I have never thought about IQ because I think the measurement of the IQ, I do not think that this is very accurate, frankly speaking. I do believe that intelligence, of course there is intelligence as a whole, but we have specialists. We have people who can extremely fast calculate in the brain. We have people who can memorize things in a very special way. So I do not think that one IQ can really is really an accurate number to describe the functioning of a brain of somebody. So,
okay.
But this is just a statement from somebody who is not knowing too much about IQ.
What about other aspects of intelligence? Do you believe that there are people with higher intelligence, people with lower intelligence, or is it just like different aspects of capabilities?
Well, intelligence, people always asking me this because people were saying, well, I was not, when I'm giving a talk in physics, for instance, about physics of James Bond, people were saying me, well, Mr. Tolan, when you would have been my teacher, I would have been much better in physics. And I'm going to tell them this is not true. You were not good in physics because you were not interested in physics. This is the real reason, not your teacher. Because I think even in sports, when you train hard enough, you can at least come to a certain level which makes you not to a world record holder, but which makes you better than others. I experienced this when I was, I think, for 25 years ago, when I had a competition with a PhD student to running 100 meters as fast as we can. And I was doing some training, and I was hiding this from him so that he was not knowing this. And He was, of course, faster than me, or he was expected to be faster than me, but I was able to run and to came very close to him due to the training. And I came even close to the time of 100 for a 100-meter run, the time which I achieved when I was a school kid, when I was supposedly much faster, 18 years old or so. And this means that even in sports, everybody can come to a certain level. And when you do this in mathematics or in physics, when you are interested and you are willing to spend your time in it, then my feeling is everybody can at least come to a certain level which makes him able or her able to understand the basic things in mathematics and physics.
Good.
This is what I think.
Where does that interest come from? Some of us are just born fascinated with equations and the beauty of physics. Is it a worthy endeavor to try to manipulate people to be more interested in physics? Because that's what I believe in as a physics teacher. But
yeah, yes, I think so. But I think it must not be physics. It should be anything. I mean, I think a young person should have one thing with where he or she has a deep interest in, and try to learn more about this. For instance, the son of my wife, he was, when he was a young child, very interested in fishing. He was doing fishing all the time. He was interested in the fishes. And my wife was saying, well, this is good for him. And he's spending all his time in fishing. And I told her, this is good because he is interested, at least he's interested in one thing. And he wants to know something very deeply. This is good. I know a lot of kids who are interested basically in nothing. And spending their time by just, it's also interesting to hear music, but by just doing nothing. And he was interested in fishing, and he is knowing all about fish, about all fishes in the world. And so I think getting interested in one particular thing as a young person is good enough.
So what is the message to my my pupils in the school? Like, if they are not interested in physics,
find
that's
at
good.
least one thing you are interested in. It could be Latin, for instance. Yeah.
Okay, could it be something with their phone? Because that's what they do all the time, right?
It could definitely be something with their phone. With their phone, for instance, there are a lot of interesting things you can find with your phone, but with your phone you can also try to ask yourself, how are these apps working? Can I program my own?
Are you going to ask the question, or are you just going to play the game?
Can I program an app, for instance? What wish do I have? Do I have a wish, or do I think this app? Do I have a certain need which is not covered by all the apps which are existing right now? And if there is a certain need, why can't I program this app? I can learn this because there are books around or things in the internet around where you can learn the programming of apps.
I know, I tell this all the time to my students, but you also understand how it's kind of hard to take the decision, right? It's not hard to learn a program. It's hard to be motivated to take the time.
But this holds for everything. This holds for sports. This holds when you want to go deeply into one topic. Of course, it's hard to make the decision that you want to know this a little bit more and to spend now your time to figure this out.
Okay, I'm gonna turn this around. Kid, whatever, 14, 15 years old, playing on his fucking phone all the time. Is it okay? Or maybe the computer, right? Like, is it okay to play games? I used to play a lot of games when I was younger, but that's basically the opposite of being interested in something. It's being interested in that game. But is it a worthy pursuit?
I mean, being okay. I would say if you are a kid, it's fine. If you are in my age, and I'm still playing all the day such games, this would be, well, not normal, I would say. No, what I think is, when I grew up, we had a computer at home, a Commodore 64 computer. We played a lot of games, but we also asked ourselves, how is this computer working? And why can't I program my own game? And later on, we figured out that it is even more fun to program your own game rather than to play the game.
I think it's very like not representative of.
No, I don't think so. I don't think so. I do think that people are shrinking away, exactly as you were saying. That they say, well, it's too much effort, or they even say, I do not understand this. And this is not true. If you spend a little bit time into this topic, you can understand this, at least when you can read, and I expect that you can read. So, and then you have to take the time and to try and error. Programming is trying and error. Mm-hmm. And it starts from the very beginning, and you can learn this. Everybody can learn programming. And I can also tell everybody that if you learn programming nowadays, it is something for life. Learning to program a computer, it doesn't matter which computer this is something which you can need for your entire life. For instance, I learned to program a computer with a programmable pocket calculator. I had one of the first pocket computer. It was a Texas Instruments 59 computer with a magnetic strip where you can fix your program. I think it was 1,000 bytes or something like this. But with this computer, I learned programming, and I have to say the structure of programs nowadays does not significantly differ.
It's a bunch of if cycles and while cycles.
From this, what I learned there. So if you really learn programming on whatever system you have nowadays, you will benefit from this for your entire life. And I can just recommend to everybody to do this. And when you try to do it, and when you put in a couple of hours, then the fun starts.
Exactly. And I tell this all the time again to my students, because I think, and would you put your name there? Would you sign this statement? Programming is the new learning to write. Like
yes.
If you don't program in 2021, you're basically analphabetic.
Yes, and also with programming, you have the chance to understand algorithms, which is also a key feature today's. Understanding algorithms is extremely important, because only when you understand algorithms, you have at least a glimpse of an idea from what is happening with you all day long when you use Google and all the other things.
Life is an algorithm, right?
Not only life, but also the tools we are using today. When you Google something, and then you think, well, why is Google showing me up all these things which I'm interested in? Because there is an algorithm behind this. And you understand all these things much more easy. You understand our life, our modern life, better if you are able to understand algorithms and if you are able by yourself to program a computer. This is definitely true.
So what do you say to come back to this question of intelligence? So if it's all about being interested in something, if you're interested in something, then you will automatically learn it and be good in this. Is there something about it that you are born with, if you're interested or not? Or is it something that could be nurtured? Or how much is inborn, how much can be nurtured?
No idea. I can only say that all my interest was coming from myself in parts. I mean, my father is from Turkey. And my mother went only 4 years to school because she suffered from World War II, and the family was coming from the very eastern part of Germany, which now belonged to Poland. So they had no no school education, almost no school education at all, so they could not teach me. Nevertheless, my mother taught me. She taught me before I went to school. I could calculate with the numbers up to 1,000, and I could read and I could write already before I went to school, here to elementary school. This is what she did, because she spent just time with us kids. And this, of course, helped me a lot. And so I would say at least my mother triggered at least a little bit what came later on. So I would say, yes, you can trigger this, but really then being interested in science, I have the feeling this is something which has to develop by everybody by itself, and not everybody must be interested in science. They could be interested in music, in literature. I hope that a kid is interested in at least one thing, as I said, but it must not be science.
Okay. There are 1,000 employees in this building.
Yeah, yeah.
How many employees are making this place function better?
How many people are working in science, you mean? Well, from the 1,000 people, I can tell you that approximately 10% of the budget of the university is being spent for administrative personnel, and well, this is not too much. You find the same amount in every company. Approximately 10% of the budget goes to non-scientific personnel or goes to the administrative staff, and the rest of the budget goes to the scientific personnel or the teaching personnel here. So it's roughly 90%.
So it's okay. It's not skewed too much. There's not like a major gap between how much academic personnel is there and how much should be there. You just more or less. Okay.
Well, of course, you could always have more academic personnel. I think, but I still think we are here. We are here, I would say, for what we have to do in terms of teaching, for instance. We are well staffed. I'm not complaining about this. I also know that it is very simple to complain about things, but we are very well staffed for doing our duties. We could do more, of course, clearly. But we have a system here that we have to take a certain amount of students, and for a certain amount of students we get a certain amount of money, and with this money we can hire people. I think this works pretty well. I have to say this because I was also one of the persons who has developed the system for this university. so I have to say this, but I think it is really working very well.
Okay.